This video is going to look at scientific notation. And scientific notation is just a way to express very large or very small numbers. For instance, let's say that we have 9 million. We don't want to have to type in all those zeros, so we could write that as 9 times 10 to the 6th. So 9 times 10 to the 6th would be scientific notation. The 9 million we would call decimal notation or standard notation. When you look at 9 times 10 to the 6th, there's a few numbers that we need to be able to identify. The first number that you're going to see would be called the coefficient. And then the times 10 to the part has a number with it. And that number could be positive or negative, but that number that goes on the 10 is called an exponent. Now, as far as how to convert something to scientific notation, we want to take our decimal point, and even if there is no decimal point, we know that it would belong at the end of the number. So even if there's not one, we would want to put it at the end, and we would want to move the decimal until we have only one non-zero digit on our left. Then you want to count how many decimal places it took to move the decimal there, and that's going to become your exponent. If you have to move the decimal to the left, for instance, in the 9 million number, you had to move the decimal 6 places to the left, so then you have a positive exponent, just the number 6. If we need to move the decimal to the right, for instance, we might have 0.00007. We have to move our decimal to the right, so that would become a negative exponent. And sig figs will still apply. So whenever we're converting something to scientific notation, we only include the significant digits and we drop all of the non-significant. So let's go through some different examples. Some of these are already done for you. You can take a look at this first one here. You have 95,672. All of those are significant digits because they're all non-zeros. So we keep all of them as our coefficient. But notice that we've moved our decimal point over so that it's just after the 9. And then we want to count how many places did it take for us to move the decimal there, and that would be 1, 2, 3, 4. So that's where the exponent comes in. 8,340. Remember our rule for significant digits. When we have a trailing zero with no decimal place at the end, no decimal recorded, then that is a non-significant number. So notice that our coefficient is just 8.34, and we drop the 0. And then the exponent is how many places it takes to move our decimal between the 8 and the 3, and that's 3 places. So that's where that comes in. Now 100. Again, we have no decimal place, so our trailing zeros do not count. So 1 would be our coefficient, and it takes 2 places for us to move our decimal, so it's times 10 to the second. This 347,000 is 5 places, so we have 3.47625. All of those are significant, and 5 spots, so our exponent is a 5. We also need to be able to convert back into decimal notation or standard notation. So when we have this number in scientific notation, notice that 6 exponent tells us we needed to move our decimal 6 times. We originally had to move it to the left, that's why it's positive. So now we're going to move our decimal place 6 to the right to undo it. So we are going to need to add some zeros. That would be 1, 2, 3, 4, 5, 6. So there's our 6 jumps. We don't want to keep the decimal at the end though. Notice that this number dropped those trailing zeros, so they were not significant. Let's do some small examples. Having negative exponents just means that we moved our decimal place to the right, in this case 2 spots, so 1.4 and then a negative 2. Hopefully you notice that all the beginning zeros never count. It's only the trailing zeros that count, and only if there's a decimal place. So 8.0 is going to be our coefficient, and then it took 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's a negative 9 since we had to move to the right. 9.75 for this next example, And again, we're moving to the right. 1, 2, 3, 4, 5, 6. So times 10 to the negative sixth. If we have to convert back to standard notation, we have that -4, which means we need to move our decimal to the left this time, and we need to move it 4 places. So we have 1976, and we needed to move our decimal 4 places. So that's 1, 2, 3, 4. And you're going to fill in those extra bubbles there with zeros. So 0.001976.